So, how many of you guys have dealt with classifying polynomials before? Anybody? No. You're like, maybe, but I don't know what you're talking about. Okay. So, polynomial expressions are algebraic expressions that involve only the operations of multiplication and addition and subtraction. That's a multiplication sign. Okay. So for example, 2x, that's a polynomial expression. 3x squared plus 2x minus 5, that's a polynomial expression. 5 is a polynomial expression. Okay? Because the variables are involved with, only the variables are involved with multiplication and addition of different things. When we think about polynomials, we think about two things. The number of terms and the, oh wait, let's skip down here and we'll go through the sheet in order as opposed to jumping around. So you'll notice how this one has a variable being involved in division. So in other words, I'm dividing by that, right? And so the reason for this is polynomials stand for real numbers no matter what real values you substitute into the variables. If I go in here, right, and all of a sudden I put in a 5, okay, I am not allowed to divide by 0. So that's why this is not a polynomial expression, because there's a value for real numbers that does not work, okay? So this would not be a polynomial. Not. Okay? How about this? Can you think of any values for which, values of real numbers for which this one doesn't work? Well, is square rooting addition or subtraction or multiplication? No. So this is not a polynomial, but what types of numbers can you not take a square root of and stay within real numbers? Sarah might be able to really help with this.
Imaginary?
Well, or negative numbers, right? If you take a square root of a negative number, it moves outside of the real number system into the imaginary numbers. So this is not a polynomial either. Okay? Now this one's a little bit odd. And we're going to say that this is not a polynomial either. Okay? Now, as long as you're clear about this, that it's square root of 3 and then the x is next to it, that's fine. This is a polynomial, right? This is not a polynomial because that involves exponents that are not integers, okay? And then how about this? This is the variable involved in the division. Well, the variable is being divided by, but we could rewrite that as 1/7 times x, right? So it's not the variable that's being divided. Okay. So this would be a polynomial. Okay. So what we're looking for is variables that are just kind of hanging out there. We can have odd coefficients, right? They don't have to be integer coefficients. Yeah.
I'm a little bit confused on why
C is not a polynomial because it involves absolute value of the variable.
Okay.
Okay. All right. So, like I was saying, is it doing that? I guess if I put the pen down, it might work. Okay. So, polynomials are defined in two ways. The first way is by the number of terms. Numbers and variables added together are called terms. for example, this has 1, 2, 3 terms. The word polynomial means many terms. Special names special names are used for expressions that have 1, 2, or 3 terms. So let's start with this. 2. Let's see. How many wheels are on a bicycle? Oh, binomial. How many wheels are on a tricycle? Trinomial. Oh, okay. How many wheels are on a unicycle? Ah, you didn't fall for my trick. Monomial. Monomial. Right. And for any more than trinomial, we just tell you how many terms there are. So there's 4 terms, 5 terms. We would just say it has 4 terms. You all okay with that? So now we go to the next page. Numbers and variables that are multiplied together are called factors. For example, the expression 5x cubed has 4 factors. 5, x, x, and x. Now some of them repeat, and that's okay, right? Special names are given to polynomials based on the power of the term that has the greatest exponent. The variable is called of the variable. This is called the degree of the polynomial. So if the degree is 0, so for example here, right, that's called constant. In other words, it doesn't vary because there's no variable, right? There is actually a variable, but it's x to the 0 power, right? And your memory aid, I guess, could be it doesn't vary, no variable, doesn't vary, so it's constant. No vary, oh, that's terrible. Sorry. Let me do that again. No variable, so it's constant. Okay. The next one's linear. And if you put, so that's to the first power. And if you graph that, it would make a line. Linear graph. Second degree is called quadratic. And we can remember that because it's called squared, and the square has 4 sides. Third would be cubic. A cube has 3 dimensions. Okay. And then after that, it's just, there is quartic and quintic, but if I just want you to say 4th degree, 5th degree, just tell me what it is, and so on. Okay. So for example, this one we would say it's a 17th degree one. I'm going to put that down first, and then try to move it. That would help. Okay, so let's check our understanding. What's this first one?